Hey there, welcome back again. Today we are going to do two hard circles problems and I'm going to teach you both the doing it the Desmos way and the algebraic way. And I'm going to show you why trying these problems during the exam is a Desmos trap and how you can solve these problems at the end of this video in less than 50 seconds for the first problem and less than 10 seconds for the second problem. And the whole purpose of this video is to make both these hard level problems into easy level problems for you. So let's get started. The first problem. A circle in the xy plane has its center at 2, -3. Line W is a tangent to the circle at the point -1, 1. Which of the following points lies on the line W? So let's quickly try to understand this problem. There is a circle. Okay, it has a center at 2, -3 and line W is a tangent to this circle. So somewhere just write down a point -1, 1. It is a point on the circle and you're drawing a tangent at this point for this circle and you're giving the name W to this tangent. Which of the following points lies on the line W? So he's asking you which of these 4 points lies on this W. Is point A lying on W or not? Is point B lying on W or not? Is point C lying on W or not? Is point D lying on W or not? So that is the question. Now that you have understood the question, let's try to solve this on Desmos first and see why it is a Desmos trap. Let's erase the past memories from Desmos and let's try to solve this problem. First, he has given you the circle center as 2, -3. So we know from the standard equation how to write the equation of a circle. He has not given you any radius. So let's take it as r square. But he has given you one point which is lying on the circle 2, -3 and another point is -1, 1. So we can find the distance between these 2 points, which is the radius. So let's find the distance between these 2 points using the function distance. So the first point is 2, -3. The other point is -1, 1. All right. So the radius is 5. So radius square will be 25. So that is the equation of the circle. Now you can type the equation of the circle in Desmos. X minus 2, y plus 3. So that is the equation of the circle. Now what is the question? Now there is a point 1, -1, 1. So let us try to label that point in Desmos. Give it a name. Let's call it A. Shall we? Okay, we need not call it anything. Let's leave it like that. -1, 1. Now here we have a tangent sitting like this. Now there is a tangent like this. Now he is asking you in the question which of the 4 points lies on this tangent. So let's plot these 2 points, all the 4 points, all the 4 options which we have. Let's try to plot. Now this doesn't look like you're going to get a tangent because if I draw a line from this blue point towards the red, it is cutting the circle. So this is definitely not the answer. Good news. And let's go for the next point. 3, 4 is the next point. This might be the answer because if we extend from this point to this might be the answer. Let's go to the next point of the option. Option C says 5, 5. Now this is getting trickier because from this pink point as well, if I draw, this may also be a tangent. We just don't know. It can lie on the tangent. So you might have already understood that this is a trap if you try to do it on Desmos. Let's also plug in the last point 0, 2. and see where it is. The green point is sitting here, which is the last option. Now this is also a little bit tricky. As you can see, the green point as well, the green point which you are seeing could also be lying on the tangent. So let me show it to you clearly a little bit more so that you are convinced as well. So these are the four options: the blue, orange, pink or magenta, whatever you want to call this, green. So the blue is definitely not the answer. Rest of the points we are really not sure whether they are lying on the tangent or not. So this is a Desmos trap clearly. Now we have to do it the algebraic way. Let me show you how to do it. And the algebraic way is quite easy. Please pay attention. You can do this problem. So let me make this a little bit smaller so we have the space. Now, how do we do this problem algebraically? Let me explain this to you so that you are very clear and very thorough at the end of this video. So let me erase these points. First thing you need to do is you need to find the slope of this line. Now, there is a theorem which says from the center of the circle, if you draw a radius towards the tangent, this particular angle is a right angle. That is the theorem. That's what the theorem says. So once again, I'll repeat it for you. From the center of the circle, if you draw a radius towards the tangent at the point of contact, this makes an angle which is 90 degrees. So first we shall find the slope of this line, and because this angle is 90 degrees, we know the relation product of two slopes which are 90 degrees to each other should be -1. So we'll use this particular relation to find the slope of W. Let's call the slope of this line as M2. Let's call the slope of this line as M1. So how do we find the slope of M1? You already have the coordinates of these 2 points. So with these 2 coordinates, I can find the slope of the line M1, which is y2 minus y1 by x2 minus x1. So I will select this as x2 y2, this as x1 y1. So that gives me, let's now take your attention to these 2 points, y2 minus y1. So that should be 1 negative of -3 by, now take your attention to these 2 points, that should be -1 negative of 2. So that's going to give me 1 plus 3 by -3. So that is 4 by -3. So I'll use this relation now. M1 I already know, which is -4 by 3 into M2 is the slope of the line W, which is -1. So M2 is 3 by 4. Now you know the equation, you know one point on this line which is -1 comma 1, and you know the slope of this line which is 3 by 4. So you can find the equation of this straight line. So how do we do that? Now please remember, you have a point. If you have a point on a line and if you know the slope, you can find the equation of that line. So let's do that. -1 comma 1 is the point and the slope of the line is 3 by 4. 3 by 4, see here, 3 upon 4. We got that from here, this relation. So let's find the equation of the line. This is slope intercept form. You know this already. So from here, let me quickly simplify this for you. So this is 3x minus 4y plus 7 gives me 0, correct? So this is simple algebraic manipulation. 3x minus 4y plus 7 equals to 0. Now let's go back here. 3x plus 4y, is it 4y? No, it's negative y. 3x minus 4y plus 7 equals 0. Now let's try to substitute all these four options and see which one is getting satisfied. But let's try with 0, 2. If I substitute 0 here, 3 times 0 minus 4 times 2 is 8 plus 7. This is not equal to 0. I can see that. So this is ruled out. 5, 5. Let me substitute 5, 5. 3 into 5 minus 4 into 5 plus 7. Is it coming to be 0? 15 minus 20 plus 7. No, this is not equal to 0. So this is also ruled out. Let me substitute 3, 4. 3 times 3 minus 4 times 4 plus 7. 3 3s are 9, 4 4s are 16 plus 7. 9 plus 7 is 16. 16 minus 16 equal to 0. So this is the answer. 3, 4. So that is how you do the first problem. I know it's a little bit intense, but if you practice this clearly, you will be able to solve this. So let's go to the next problem. Let's read this one. Circle A has equation which is given to you, x minus 3 whole square plus y plus 5 whole square equal to 4. So this is standard equation of a circle. In the xy plane, circle B is obtained by translating circle A to right 6 units. So it's telling you this circle is translated to the right by 6 units. So if I translate a circle to right, if I translate any circle to the right, so let's say this circle is sitting at somewhere here, and if I translate this circle to right, definitely the radius is not changing for this circle. We have translated this circle to right by 6 units. So the translation is only happening along the x direction, nothing is happening along the y direction. So this is the understanding of the question. Now what is the question is asking you? This is circle A, this is circle B. Is asking you the equation of circle B. So the first thing that you need to understand is equation of circle B and equation of circle A both have the same radius, because we are only translating it, we are not increasing or decreasing the radius. So this is the first understanding. So the only thing that's changing is the center of the circle. The radius is remaining exactly the same. So the right hand side will have the same 4 that should be sitting in, that is sitting in all the options. So that is cool. So the only thing now that has to change is the center. So first let's do it with Desmos, and then I'll show you how to do it with the algebra. Let's go to Desmos. In the Desmos, let us forget the past memories so that they don't interfere with our present. Please do that in the exam hall as well. Now what do we have here? Please type the equation in the Desmos. Something square plus something square is equal to 4. So this comes out to be x minus x negative 3, y plus 5, yes, y plus 5. So that is the equation of the circle. So that is the circle, and then we want to shift this. So there is an easy way. You need not type this again in the exam. You go to the gear option and then copy. So that's how you do it, so that it saves a lot of your time in the exam. And then what you're going to do is, if the question says, now please pay attention here, the question is telling you it is shifted by right. So what is shifted? The x coordinate. So this guy is shifted by right 6 units. So how you are going to translate that in Desmos? Now give a little bit respect to x, because something is happening there. And if it is shifted by right, you are going to subtract it by 6. If the question says it is shifted to left, you should add that much to the x coordinate. Because it is shifted to the right, you subtract. So remember, if it is shifting to right, you subtract. How much? By as many units as it is getting shifted. So let me change this color to some other color so that we are very clear. So this is the original circle which is in white. The shifted circle is at orange. So what is the question is asking you to find the equation of the shifted orange circle. So that's the question. Now you can simplify this. Now how do we do this? Look at this shifted equation, write it down here. X minus 6 minus 3 whole square plus y plus 5 whole square is equal to 4. Simplify this, it comes out to be x minus 9 whole square plus y plus 5 whole square equal to 4. Let's see which option is matching. So this is matching here. So this is how you do it using Desmos. Okay, now suppose you want to find the center of this circle without using this particular formula. Let me show it to you how. So go to this circle, find the extreme points. So 9 comma minus 3 is the topmost point for this shifted circle. Let me show it to you. And the bottommost point is 9 comma minus 7. So the midpoint of this gives you the center of the circle. You can find the midpoint using the midpoint function. If you don't want to do it using algebra at all, you can, I'm showing you how to do it. First you write down the template. What are the 2 points? One point is 9 comma minus 3, 9 comma minus 3. The other point is 9 comma minus 7, 9 comma minus 7. So 9 comma minus 5 is the midpoint. So since you know the midpoint, now you can directly write the equation of the circle. 4 is already there, which is constant, you already know. So x 9 comma minus 5. So x flip the sign, x minus 9. For y also flip the sign. So this is what we have got, exactly the same thing. So I have shown you how to do it with 100% Desmos, and the algebraic way is the smartest and the fastest way to do this problem, which I have already shown you here. Where is it? This is how you do it algebraically. Shift the x by whatever is the translation. If it is shifting towards right, you subtract it from the exact value of x, just like we have done here. Alright, so that is what this video is all about. So what we have learned in this video so far. So the first problem is a Desmos trap, clearly, because you try to do this on Desmos, you will end up with 4 points, and you have to visually figure out which is the tangent. That is a risky job to do during the exam. So you have to do it the hard way, the algebraic way. But the algebraic way, the only key points that you have to remember is, this is the key point that you have to remember. So what did we do? We have found the slope of this line. Using this relation, we have found the slope of this line. And then we have found the equation of this particular line W. After we have found the equation of this line W, we have substituted all these 4 points and checked which of the points satisfy this particular equation, and from there we have figured out the answer. So doing it the Desmos way is a trap. You're losing a lot of time during the exam. So please learn this algebraic way. Watch this video multiple times if it is not, you're not got this in first round. And how do we do the second problem? The second problem is quite straightforward. If you do it on Desmos as well, it's going to take you a little bit more time. So I would prefer to do this in the algebraic way. So he's telling you the equation is shifted towards the right by 6 units. So when the shift is happening by 6 units, for this substitute whatever is x, because the shift is happening by 6 units towards the right, instead of x write down x minus 6, and that is the equation of the new circle. So the equation of new circle is x minus 6 minus 3 whole square plus y plus 5 whole square equal to 4. So that is how straightforward it is using algebra. So as I have told you, this problem, if you use the algebraic way, you can solve this in less than 10 seconds. And if you seriously practice this method which I have told you, you can master. If you once master this method, you can solve this particular problem in less than 50 seconds. And remember, it is a Desmos trap. So please don't do it with Desmos, do it with algebra, this one. This you can also do it with Desmos. It's not a trap. It's going to take time. So this is how you make hard problems easy. Practice this problem couple of times and I'm quite sure that you can do this within less than 50 seconds. So thank you so much. If you have liked this video, like, share, subscribe, and see you in the next video for circles. Bye bye.